Hello, this is Geometry, Notes 4-6, Isosceles, and Equilateral Triangles with Mrs. Mosley. Go ahead and do the warm-up. As you're doing it, go ahead and pause this video. When you are done, go ahead and unpause it. Okay, who got B for an answer? Good job, that is correct. The quickest way to approach this problem is to think about vertical and horizontal pieces. These two pieces add to get the total of these two pieces over here. So those two pieces also add up to 20. And then horizontally, we have the 20 on the base, and then that width across is also 20. So we have a total of 20 plus 20 plus 20 plus 20, which is 80. So good job if you got B. Let's go ahead and finish this chapter with the isosceles and equilateral triangle theorem. So isosceles triangle theorem says if we are given two sides are congruent in a triangle, meaning we have an isosceles triangle, then what we're going to prove is that the base angles are congruent. Now, a quick way to prove this is there's a proof that is typed out below. What you do is you start off with an equilateral triangle and then you draw in an auxiliary line segment. And that auxiliary line segment, go ahead and while you're drawing it, you are creating it to be the bisector of line segment CB. Since it bisects line segment CB, line segment CT is congruent to line segment BT by the definition of segment bisector. Okay, or you can say that it's a midpoint. So by definition of midpoint, those two pieces are congruent. And then you have your reflexive statement. Therefore, by side, 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 the two triangles are congruent. And then by CP-CTC, corresponding parts of congruent triangles are congruent. Let's write that down. Corresponding parts of congruent triangles are congruent. By CP-CTC, corresponding parts are congruent. So these corresponding base angles are congruent. Therefore, if you are given any isosceles triangle, base angles are congruent. On the converse is when you switch the if and then around. The converse states that if you start with base angles being congruent, so I'll show that. If that is true, then we have conversely, then it is a isosceles triangle. A quick way to prove that, we won't go through the steps of that, is you draw in an auxiliary line segment that is an angle bisector. And then you can say by the reflexive property, this segment is congruent to itself. So we have an angle, angle, side. So angle, skip a side, angle, side, angle, angle, side, angle, angle, side. So by CP-CTC, since the two triangles are congruent, corresponding parts are also congruent of congruent triangles. Therefore, these corresponding sides are the same. So if you have base angles congruent, then it is an isosceles triangle. If it is an isosceles triangle, then the base angles are congruent. Let's review. In an isosceles triangle, the two sides that are congruent are called the legs. The base is the non-congruent side, and these would be called the base angles. Base angle, and here's another base angle. And then this up here is called the vertex angle. It's good to know these vocabulary words, so if you are given a problem with those words, you understand what you're finding. So vertex angle is the non-congruent angle. Let's go to the back side, do some algebraic problems based on the isosceles triangle theorem and the converse of the isosceles triangle theorem. Number 1, we are given in a triangle, base angles are congruent. Therefore, by the converse of the isosceles triangle theorem, it is an isosceles triangle. So those opposite sides are congruent. So we'll say converse of the isosceles triangle theorem. You can call it ITT once on your paper, but before you can write out ITT, please make sure you are giving me the words. So this is isosceles triangle theorem. Feel free to use the symbol for triangle and THM for theorem. So we know that 9 is equal to 2z minus 15. Add 15 to both sides, so we have 24 equals 2z. Divide both sides by 2, so we get z is 12. Next problem, we want to find x, y, and z. Well, we know that this is an isosceles triangle, so by the isosceles triangle theorem, or just say ITT because we've already written out isosceles triangle theorem, by the isosceles triangle theorem, the base angles are congruent. So we know that z is also 40 degrees. And we know that by triangle angle sum theorem, in a triangle, the angle sum is 180. So all three of these angles add to 180. 4x minus 8 plus 40 plus 40 is 180. So we have 4x minus 8 plus 80 equals 180. Or in other words, 4x plus 72 equals 180. Subtract 72 from both sides, and you get 108. Divide both sides by 4, and what do we get? We get 27. So x is 27, and then lastly, we want to find y. Well, this is a isosceles triangle, so these two sides are the same in length. So 8y minus 5 equals 6y plus 3. So solve for y. Let's subtract 6y from both sides. Add 5. So we have 2y equals 8. Divide both sides by 2. So you get y is 4. Next problem. We have two sets of isosceles triangles. Let's look at the left one. Since this is, let's use a color, let's say blue. And so this left triangle, my light blue triangle, is an isosceles triangle. So that by the isosceles triangle theorem, those base angles are the same. So isosceles triangle theorem tells us that y and y are the same. And we know by the triangle angle sum theorem test, we know that 112 plus y is 180. Three angles of a triangle add to 180. So we will solve for y. So 2y equals, what is that? Oops, 112. So 180 minus 112 is 68. Divide both sides by 2, so we get y is 34. Once you get that, now we're going to go to the next triangle. Let's go ahead and change colors. I'll just use purple. And now we have another isosceles triangle. So these two angles are the same. So I can use a triangle angle sum theorem as well as a supplement theorem. These two angles, let me call this z. Y and z are supplementary, or in other words, the best vocabulary word for y and z is they form a linear pair. So y and z form a linear pair, and by the supplement theorem, they added 180. So since y is 34, we know that 34 plus z equals 180. And so subtract 34 from both sides. So we get 146. So now we know by the isosceles triangle theorem that this is also x, those base angles. So z plus x by the triangle angle sum theorem is 180. So z is 146 plus 2x is 180. Subtract 146 from both sides. So we get 2x equals, what is that, 34? Divide both sides by 2, and x is 17. It's a lovely problem using our geometry rules as well as a lot of algebra. Okay, last thing I want to teach you in this section is that if you have an equilateral triangle, then it's going to be also equiangular. So if that is true, then the base angles are the same. So for instance, um, think about this triangle being an isosceles triangle with those two as the legs. Therefore, the base angles are congruent. If you look at another two sides of the original triangle, let's say like this side and this side, then those base angles are the same. So therefore, um, we're using the same understanding of, or the reasons of proving the isosceles triangle theorem as we are here. Nevertheless, just know if it's equiangular, it's going to be equilateral. Also, if it's going to be equilateral, it'll be equiangular. So the converse is also true. So go ahead and mark up your next triangles. So your if statement is going to be the angles are all congruent. The then statement, in addition to those angles being congruent, the opposite sides or all of the sides are congruent. So we'll get there in just a bit. It's kind of good that my computer stops. It doesn't respond for a while because it gives you guys a chance to try it on your own. So go ahead and fill out those pictures and then I'll catch up to you. So this was our if statement. This is our then statement. If we have an equiangular triangle, then we also have an equilateral triangle. So this is just called the, I just say this is just isosceles triangle theorem, and you just apply it twice. So if you have an equilateral triangle, all sides are the same, then we know it's equiangular, which also means that all sides are the same and all angles then would be 60 degrees. Have some good times doing the application problems to this section. And as always, if you have questions, go back to the notes and also ask around. Have a great day and hope you guys are doing well.